What's going on, guys? Welcome back to another video. And in today's video, we'll be going over linked list in Python. Before we talk about linked list, this is just a quick reminder to please hit the subscribe button below. It will really mean a lot to me. Let's get right into it. Now, the idea of a linked list is actually very interesting. It's part of a larger universal concept. It's an abstract data structure, and we as the users, we're defining a linked list. So what exactly is a linked list? Well, it's a sequence of data elements, and each data element is a reference to the next data element. So they're linked together. That's why it's called a linked list. Okay? So every data element is called a node. And you're going to hear nodes a lot as you start getting into user-defined data structures and really these higher level programming concepts. So a node is just a data structure, and a node contains two things. One, it contains a piece of data or a data type, and two, it contains a reference to another node or the reference none type or null type, okay? So you really have to keep that in mind because we're going to be defining our own nodes, and we're going to use nodes to define our linked list. Okay? Now with linked list, it really helps to visualize what's going on in memory. So you're probably already familiar with the idea of lists and arrays. And what that would look like is you normally have sort of like a box, right? And this would just have elements in it, so 2, 3, 4, 5. So this would be a typical list, right? And you can see it's contiguous and it's stored in like blocks in memory, right? Now a linked list would look something like this. So we will have a node. So this is what a node would look like. And like I said, a node contains a data element. So say we have an integer 2, and it would contain a reference to another node. So this would be our reference, and our reference would point to another node. And this node would contain the same thing. It would contain a data element and a reference to another node. And we'll just keep going on until we reach the end of the list. Now, once we reach the end of the list, the last element in the linked list, it contains a reference to none in Python. So this would just be none. Okay? So now I'm going to introduce a few terms. So we know that this is a node. So this is called a node. This data structure here is a node. It contains a data element and it contains a reference to another node. This, the very first element in your list, is called a head. Okay? So the first element in the list is the head, and this is really to make sure that we're keeping track of elements. And sometimes in a linked list, you may have a tail. So the last element in the list may be known as a tail. You may have that, you may not, you don't need it, but it's good for certain situations to know what the last element in the list is, okay? So this is what a linked list would look like in memory. Now, it may not be obvious for the advantages of a linked list. So why would we use a linked list over a list? Well, for a list, if we wanted to add an element to the front of the list, for example, to do this, what Python does is it will have to shift all of the elements in the list over one to add an element to the front of the list. So say we wanted to add the element, how many boxes did I have? 1, 2, 3, 4, 5, 6. So say I wanted to add the element 6 to the front of the list. To do that, Python, it would have to iterate through this list, right? The first list. We'll have to create a new list, essentially, copy the elements to the new list, and then to a new list that's slightly bigger than the old list, and then add the 6 to the front of the list. So that's really the process of how it would add an item to the front of the list. Now it may optimize it. We won't talk about that, but and all in all, to add an item to the front of the list, the operation is big O of N, because it has to iterate through the entire list to get all of the elements and really copy them into another list. So big O of N to add an element to the front of the list. Well, for a linked list, to add an element to the front of the list is very easy. say I wanted to add the element 6 to the front of this list. Well, if I created a new node, the node's next reference would be none. So if I wanted to create a new node, this is what it would look like. And to add it to the front of the list, all we have to do is we have to point this, instead of this pointing to none, we're going to point this to the head reference, right? So now this new node that I'm adding to the front of the list is pointing to the head. And all we have to do is point the head to this new reference. So if that makes sense, what we're doing is we're putting this next reference to the original first element in the list. Then we're telling the list that the head of the list is now this new element. So now to draw a better picture, it looks like this. So head would be 6, 6 would be 2, and then so on and so forth, right? So this is what we'd have now. And that is constant time. So that took one step to add an element to the front of the list. That's big O of 1. That's as fast as you can get. That's perfect. Okay? Same thing for removing an element. If we wanted to remove an element, it would just be that. So that's why we use linked list, because when it comes to adding and removing elements, it's very quick and easy. You don't have to iterate through the entire list and copy elements like you would with a regular list. Now, a downfall to a linked list is that it does not support random access. Now, what does that mean? Well, in a list in Python, if you want the element, say I wanted this item 3 in a list, this is the third element in the list. If I had the index of that number, I could just get this element easily. So if I said, give me the third index, it would immediately go to this box right here and it'll give me the number 3. That's random access. I can access that element just like that because I have the index. And for a linked list, what if I wanted this element 4? There's no index number. There's nothing that I can use to immediately go to this box and get the number 4. So in order to do that, I'll have to iterate through this linked list and find this number 4 in order to get the data. So that's the disadvantage of a linked list, is that it does not support random access, unlike a list. Okay, now I hope you understand the concept of a linked list. You've seen the diagram, you see how it's different from a list. Now it's actually time to program one. Now, when programming a linked list, it's very important that we visualize what's happening. So first thing we're going to do is we're going to program a node. And I mentioned that a node is just a data structure with two things. It has its data, and then it has a reference to another node. So keeping that in mind, when we go to code our node, we have to ensure that the node has these two elements. So to code a node, we're literally starting from scratch. We're going to create a class called node. Okay. And every node is going to have taken a parameter or an argument of the data type. So this data could be anything. It could be an integer, string, whatever. So first thing we're going to do is we have to create an initialization method. Okay, so this is standard object-oriented programming stuff. Now, like I said, when we create a node, we're gonna pass a piece of data. So it's gonna take one argument, and that's the data. And then I'm going to do self.data equals data. And then it also has a reference to another node. Now, by default, every node, when we create a node, its next reference, we're gonna call it next. So self.next is going to be set to none. So when we create a node, we're going to have a next reference. Every node has a next reference or a reference to another node. Well, when we first create a node, this reference is equal to none until we add it to a linked list, okay? So right now we're just defining the data structure, and now we have to actually implement it into our linked list. So this is it for node. That's all we have to do. Like I said, we have its data and we have its next reference. Okay. So now we're actually going to implement our linked list. Okay. So to do this, we're going to create a class called linked list. Okay. And a linked list, if you remember, it contains a head. So we have to create a head, and we could add the size of the linked list just for convenience. So I'm going to define an initialization method. And I don't need this. And we're going to first set the head reference to self.head equals none. So when we first create a linked list, it's gonna be empty. So we have an empty linked list, and the head reference just points to none. And we're gonna set the size to 0. So right now we're creating a linked list. So when we instantiate a linked list, it's going to be empty until we add elements to it. So now we're actually gonna create a function to add elements. So we can do a few things. We can add to the front of the list. We can add to the end of the list. We can add to a position in the list. We're going to start with the basic adding to the front of the list. So I actually demonstrated this earlier. So I'm going to create a function called add to front. And we're going to pass in a piece of data. So say we want to input the number 6 into a linked list, then this is what, I have to pass self as an argument as well. So we're going to pass in self and then data. So whatever we want to add to the list. Okay. Now, first thing we have to do is we have to create a node. So this is the node that we're adding to the linked list. So I'm going to do node equals an instance of this node, a class here that we defined earlier. And I'm passing in the argument data. So the data element that I want passed in the linked list, I have to put it inside of this node. So it's a part of the node, right? And we're adding this node to the linked list with this data in it. Okay. Now, when we add to the front, we have to consider a few things. We have to consider, is the list empty already? Is it have more than one element? Is it not empty? Stuff like that. So if the list is empty, well, then it changes how we add it to the front of the list, because the first element that we add to the list is next reference is none, if that makes sense. So what I'm going to do is if self.size is less than 1, so if the list is empty, we're going to set the head. So this is very important when we want to define our methods. We want to be able to visualize what's going on. So I'm going to have a drawing of what's going on while I write this method. So if the size is less than 1, so if the list is empty, I'm going to set this node dot next. So the node's next reference is none because it's the first element in the list. So there's no elements after it. So its next reference is none. Its default next is none. So when we create a node, you can see that its next reference is by default none. This is just precautionary, so we don't have to put this, but this is just for good practice. And we're setting the head reference to be the node. Okay, so head equals node. Okay, so here we literally have, I'm going to do self.head actually. So the self.head equals node. So the head reference points to the node, and the node's next reference points to none. So if that's only if the list was originally empty, so now we have one element in the list. If we have more than one element in the list, well, then that changes things just slightly. So if we think about it, the heads reference will, if we have more than one element in the list, the heads reference will be pointing to a node, that node will be pointing to another node, and so on. So we want to add a node, and we want the node to point to what the head reference was pointing to, and then the head to point to the node that we're adding. So this is actually the exact same thing that I did on paper earlier, but I'll show it again just so we're on the same page. So this new node that I created, I want this node's reference, so node.next, to equal the head reference, so self.head. Okay? And now I want to point the self.head reference to equal node. Again, visualizing this will make it make more sense. So we have this new node that we created and we want to add it to the front of the list. We're pointing it to the head's original reference. So now the new node that we're creating points to the head's original reference. Now the head is pointing to this new node. So we just rearrange the ordering of the linked list. And again, this is big O of one. This takes one step. This is very simple. We're just rearranging references. We're not iterating. There's no for loops, none of that. Okay? So that's it for the add to front. Now to test this out, we have to actually write a print method. So I'm going to define a function called print list. Okay. And all I'm going to do is I'm going to start from the front of the list. So to do this, and I'm going to do self here. I'm going to create a node, and this node is going to be called cur. So cur means current, and we have to start from the front of the list. So remember, the front of the list is always the head. So I'm going to set the cur equal to head. So cur equals self.head. I always forget the self.head. And what I'm going to do to iterate through this list, all we have to do is we have to say that the current element is not equal to none. So remember, the last element points to none. So while the current element is not equal to none, we're going to iterate through this list. So while cur is not none, we're going to print the data. So we want the data. So we want to print cur.data. So whatever is in the node, we want to print. So remember, cur is a node. We want to print whatever data is in the node. And to iterate, we have to actually move cur, right? So we can't have cur just equals self.head the whole time. To actually iterate through the list, we have to set cur equal to cur.next after we filling out the data. So cur equals cur.next. So remember, cur.next is just a reference to the next node. So that's how we iterate through a linked list, by getting cur's next reference. Okay. So this is all we have to do. And it's going to iterate through the list until cur is equal to none. So once cur is none, or cur is the last element in the list, then it will stop. Okay. So let's try this. Let's create a new list. So my list equals linked list. And we have one method here to add elements to the list, that's adds to front. So I'm going to do my list.add to front. Let's do 1, and then 2 and 3. So since we're adding to the front, this should print out 3, 2, 1. Okay, since we're kind of adding it in a reversed manner. So once I do my list.print list, this should print out 3, 2, 1. Let's see if we did this correctly. And we're just getting 3 forever. So I made a very silly mistake here. I put cur.next. This should be cur equals cur.next. That's my fault. So cur equals cur.next. We can't just put cur.next. It's not doing anything. Also, I forgot that we have to increment the size variable. So every time we add and remove elements from the linked list, we have to increment the size variable so that our functions actually work, right? So we can do self.size plus equals 1. And that's because we're adding items to the list. So every time we add an item, we want to increment size by 1. So now let's try this, and hopefully this works. And as you can see, it does print out 3, 2, 1. Okay. Now to add an item to the end of the list, it's actually pretty easy. It could be easier and more efficient if we had the tail reference that I was referring to earlier in the video. But since we don't have a tail, we have to iterate through the entire list and then add the item to the end of the list. So again, to iterate through the list, I'm going to create a new method called define add to end. It's going to take in self and data. Okay, so again, we're going to create a node and adding to the end. If the list is less than 1, so the list size is less than 1, if it's empty, it's the same thing as adding to the front. We're setting the node.next to none, and we're setting the head to the node. So I'm just going to copy and paste this right here. Else, this is where we have to traverse the list. So we have to go through the entire list all the way until the last item in the list. So how do we know what the last item in the list is? Well, if you visualize this, the last item in the list is the items whose next reference is none. Okay, so if the next reference is none, that's how we know the item is the last item in the list. And that's where we want to add our element. Okay, so first thing we're going to do is we've already established how to traverse a list. So I'm just going to copy and paste this block of code that we had for traversing the list to print the list. Okay, except we're not printing. So this is how we traditionally traverse a linked list. Just these 3 lines of code here. Now, while we're traversing the list, we're going to do if cur.next equals none. So if it's the last item in the list, then what do we want to do? Well, if it's the last item in the list, we want to take the last item in the list, point it to the new node that we're creating or inserting into the list, and then we're setting the new node's reference to be none, which it already is by default. So first thing we're going to do is we're going to set the new node that we're creating equal to none. So node.next equals none. So its next reference is none. And now the previous last element in the list, we're going to set this equal to node. Okay. So again, I'm going to add the visualization of this so you can see exactly what's going on. So cur.next equals node. Now, I have to put double equals here. Okay. Now, this seems fine. It looks right, but we have to break out of this loop. So once this condition is satisfied, we want to break out of this loop, or else this program is just going to break essentially. And so I'm just going to put a break statement here. So this tells us that we've reached the end of the loop and we just want to break out of it. So what do we call this? Add to end. So right now the list is 3, 2, 1. Let's make it 3, 2, 1, 0. So I'm going to do my list.add to end and then 0. So it should be 3, 2, 1, 0. And it is. Works just fine. That's perfect. Now that we've added a method to add an element to the front and the end of the list, I want you to think about how we would remove an element from the list. So hopefully you're grasping the concept of a linked list, and think about how we would remove an element from a linked list. Make sure to draw out the picture and visualize what's going on, and think about how you would remove an element. So I want you to try and implement it yourself, and then once you feel you've done it, come back to this video and I'm going to have my implementation on the video and I'm going to go through it. Okay. So here's my implementation for removing an item from a list. So the first thing I'm going to do is I'm going to check if the item that we're trying to remove is equal to the first item in the list. So if it's equal to the head item. So if the head reference is pointing to the item that we want to remove, well, all we're going to do is we're going to point the head to the item that we want to remove's next reference. So we're just skipping over the item we want to remove. And I'm going to show a diagram of this, but really all we're doing is we're just skipping over the first item in the list, and then we're just returning nothing. So we're just ending the function. And this is a very quick and easy implementation of removing the first item in the list. This takes that much time. Now, if that's not the case, if the item is anywhere else in the list besides the first element, then we're going to create a variable called cur, and this is just going to be the first, it's going to point to the head. So it's going to be the first item in the list, and we're going to iterate through the list to find the element if such element exists. So again, we're iterating through the list. We've done this. So while cur is not none. So if the data of the current element is equal to the data that we're looking for, so for example, if the node has 3 in it and we're looking to remove 3, we're going to break out of this loop and we're going to do this step down here. But if not, we're going to set previous equal to cur. So prev equals curs. So this is how we keep track of the previous element in the list and then the current element in the list, because we need the previous element in the list so we can skip over the current element. So we're going to set previous equal to cur, and then cur is just going to be the next reference. Okay, so now we're iterating one by one, but we're also keeping track of the last element in the list, right? Now, the next step is if the item is not in the list, if cur equals none, so cur reaches the end of the list, we're just going to return nothing. So the item was not found, it's not going to return anything. But back to this case right here, if the current data is equal to data, so if we found the element, we're going to break out of this while loop. We have the previous element in the list, so we're going to set the previous elements in the list to the current element's next reference, okay? So really the current element in the list, cur, all we're doing is we're skipping over it. So we have the current element and we have the previous element. The previous element's next reference is going to be the current element's next reference. So the previous element's next reference is not cur anymore, it's cur's next reference. So nothing is pointing to cur, so cur is not a part of this linked list anymore. So that's how we're removing an element from the list. We're essentially saying that nothing is pointing to the element that we want to remove. Okay? So hopefully your implementation was similar. This also removes, it removes all instances of an element. It removes one instance. So for example, I tested now here. So if I wanted to remove 1 from the original list, you can see that 1 is gone. However, say I just added 1 to the end here. Actually, no, add it to the front. Add 1 to the front. You can see that 1 is still here. So it removes an element one by one. Now, this is all I'm going to do for this linked list video. I do have some challenges for you though. You can try to implement a method that removes all the instances. You can also add an insert method. So we just added a method that adds to the front and end of the list. What if you wanted to insert somewhere in the list, right? So you could try that. And that would do it for this video. If you enjoyed this video, if you learned something, make sure to like, comment, and subscribe. And I hope to see you in the next one. Take it easy.